Continuing chapter 7, here I want to talk about comparison instruction. We're going to cover comparison instruction here in this lecture. Comparison instruction compares two sets of data. So it will compare the content of a memory location with the content of another memory location. Something that is interesting about comparison instruction, and you should be careful about, is the fact that whatever you've learned up to here, they were mostly output instruction. But here when we're talking about comparison instruction, they are input instruction. So you should be careful about this part. So if you're based on comparison, you have a you can have a true statement or you can have a false statement, and that statement can turn on or turn off your output, or in another word, it can keep the input wrong to have continuity, or it can interrupt the continuity of your input wrong. So it is really important to consider that this instruction is an input instruction. Now let's look at different type of Allen-Bradley's comparison instruction. Here you can see the list of different comparison instruction that you might see in different type of Allen-Bradley's PLC program. So we have EQU. It basically tests if two values are equal. So if they are equal, you have true statement. If they are not equal, your statement is false. NEQ, it tests if two values are not equal. So in order to have a true statement, the two values that you are having as your source A and B should not be equal. The next one is LES, so it tests if one value is less than the other one. GRT stands for greater, so it tests if the value is greater than the other one. And then we have LEQ. It tests if one value is less than or equal. And GEQ tests if it's greater than or equal. And then we have MEQ and LIM that I'm going to talk about them in more detail. These, what we discussed up to here, these they are very simple and straightforward, and even the name tells you what is the comparison instruction and how you can use this instruction when the output is going to be false and when the output is going to be true. But before going forward, let me go back to the previous slide and talk about different way that you can provide values for source A and B. So this comparison instruction, they basically compare source A and source B. Now, how you can provide the value as your source A or B? There are four different ways to enter these numbers. So these number can be numerical values. So you can just enter your number. It's 100, it's 110. So it can be a numerical value. Or it can be a program constant. So for example, you might use the timer preset, you might use your counter accumulator value. So it can be a program constant. Or it can be any value, any data from integer file, which is N7 file, or from floating point data, so F8. So you can provide your source A and source B in these different forms. Now let's look at these examples for some of those comparison instructions. So for example, here we have NEQ. So if the values are not equal together, not equal each other, your output will be on, and if they are equal, your output will be off. So the value for source A is provided in your integer file, and the value of source B is just 345. It's directly provided as your source B. In this one, we have equivalent comparison instruction. So EQU. Source A is your B3:2. So basically that means you're focusing on B3 file, and the whole word that you have as B3:2 2. So this whole block is what we are comparing here, and it is being compared with the accumulator value of counter number 2. So these are different ways of providing the number for your comparison instruction, and it also shows you that they are at the left hand side of your wrong because they are input instructions. Now let's go to MEQ. MEQ stands for masked equal to. So it will test and it will compare two sources of data that are masked over some of the bits. So if the masked areas are equal, then the instruction is true. If otherwise, it is going to be false. So how does it work? Let me show you with an example. So here you can see an MEQ. So you have a source and you have a compare. So this what is supposed to happen is that the source and compare are supposed to be compared with each other only at those value of the mask that are equal to 1. So if you have 1, so if your mask is equal to 1, then the values needs to be compared. If the mask value is equal to 0, then those value needs to be ignored. So now let's look at here. So if you're comparing your integer number at n7:4 with the accumulator value of counter 0, the only bit that you need to compare is basically bit. So this is your max 0 0 0 0 for the first 0. Then you have 1 1 1 1, and then 0 0 0 0 0 0 0 0. So basically these are the only 1 values, and bit number 4, 5, 6, and 7 are the only bits that will be compared in your integer file and your accumulator. So if these 4 bits are exactly the same, then you're going to have true. If they're not equal, then it's going to be false. Let me show you that with an example. Okay, let's assume that our accumulator value is, so the counter C5 0 ACC has a value equal to 1 0 1 0 1 1 0 0 0 0 0 1, and then 0 0 0 1. And our integer file n7 4, the n74 is equal to 1 0 1 0 1 1 0 1 0 0 0 1, and then 1 1 1 1. Let's assume that this is the first one is my accumulator value of counter 0, and the next one is the integer number I have at n7:4. Now I'm assuming that my mask number is 0 0 F0. So this is a hex number. I have to describe its binary first. The binary of this 00F0 is equal to 0000 0000 1111, and then 0000. Now, according to this mask value, the only thing I have to compare is these 4 bits. Why? Because this is the only portion of my mask bit that is equal to 1. So it means that if the associated bits in my compare and source are equal, then the result of my instruction is a true statement, which happens here. So because this is equal to this one, no matter what happens with the rest of the bit, I can say the result of instruction is true. Okay, now let's go to the last comparison instruction that we want to talk about. The last one is The last one is LIM, and LIM basically checks if a test value is either inside or outside a lower and higher limit range. So we have a lower and higher limit range, and this particular instruction checks if the value is inside or outside of the range. Now the question is that when this instruction is true. This instruction is true if I have a lower limit a smaller than higher limit and the test parameter is inside the limit. There is another scenario that you might have a true statement. So this is the first scenario that you have a true statement. The second scenario is that let's assume that for some reason your lower limit is greater or equal to your higher limit. In this scenario, your test parameter should be outside of the range in order to have a true statement. So here you need to have your test parameter outside of limits. So you're going to have a true statement. So let me show you the statement here. So this is an example. In this example, my lower limit is 100, my higher limit is 125. So now the accumulator value of T4:0 will be tested, and if the accumulator is somewhere between 100 and 125, I'm going to have a true statement. But remember that if for some reason I'm setting my lower limit as 150 and now my higher limit is 125, so my higher limit is smaller than my lower limit. In this scenario, in order to have continuity over this instruction, I need to have an accumulator which is outside of this range. So the accumulator should be greater than 150 or smaller than 125 in order to bring continuity over this instruction. Okay, so that's all we needed to know regarding comparison instruction.